We're looking at this problem here, and notice the first thing it says is terminal velocity. Let's talk about terminal velocity for a second. So terminal velocity is when you can't go any faster when you're jumping out of an airplane or something like that. And that literally means that the force is zero, right? If the force is zero, then we know the acceleration is zero too. F equals ma, right? So if there's no force on a mass, that must be the acceleration must be zero as well. So let's look at what exactly this looks like. So let's say there's a skydiver, he's fallen, or she's fallen, and going down. Now we know that there's going to be air resistance, right? And we can call that force drag. And then there's also another force going on, which is the force of gravity, and it is pulling down. So let's make this system here, and then there's another force pulling down, and that's the force of gravity. And these two forces at terminal velocity, right, that means the force is zero. So that means when you add these two forces together, force of gravity plus force drag is going to be zero. So that must mean that one's positive, one's negative, and they add up to be zero. So the force of gravity, we already know that this one's negative because it's pulling downwards. And we already know that this one's positive because it's pushing upwards. All right, so then I'm going to say, if we just take the absolute value, make them both positive basically, right? The absolute value, or the magnitude of the force of gravity, equals the magnitude force drag. And so what I'm going to do now is I'm just going to replace this force drag here with force gravity equals 1/2 CQAV squared. And then I'm going to also make another substitution. Force of gravity is mass times acceleration, right? We learned that from forces 1 packet. So that's going to be 1/2 CQAV squared. So now all we have to do to find what the question is asking, which is the velocity, it wants us to find this one, is just fill in all these variables and we are done. So the mass, it says 80. It's given to us in the problem. Acceleration due to gravity is 10 meters per second squared. That's a 1/2. Now we're looking at the C, where C is the drag coefficient. Now we got to look that up. And so it says falling head first. So let's go ahead and look at this. So it's not this situation, it's a head first situation. So look up C. So we have skydiver horizontal and then skydiver foot first. So foot first and head first, looks like this is the one that's close. And so we'll just use this value here at 0.7. So that's going to be 0.7. Now we're looking at Q, the density of the fluid. Now we're only using two Q values in this section, which is Mars and Earth. And Mars has a thinner atmosphere, so it's going to have a smaller Q value because it has less density. So let's look at that now, look this up. And we find that we have two Q values, and the density of Mars' atmosphere is less than the density of Earth's atmosphere. And we can assume we're on Earth, so we're just going to use 1. So, okay, use 1. Now we're looking at A, the area, and it says right here, it's 0.14. 0.14 V squared. So 80 times 10, 800, equals 1/2, 0.71 times 1 times 0.14. Let me get my calculator, and we get 0.049 v squared. I'm going to divide both sides by 0.049. And I get 16,326. Actually, 327 v squared. I'm going to take the square root of both sides, and I get 128. And I get a plus and minus 128. Now we got to figure out, is this going to be the positive 128 or negative 128? So this skydiver is going down naturally, right? So the velocity is negative. So we choose the negative one, which is negative 128 meters per second. And we got it.